Hi, all of you. Welcome to the next class. As you are all aware that I am going to solve hot model questions which have good probability of appearing in your final SSLC board examinations. ओम ज्ञानतिमिरान्धस्य ज्ञानाञ्जनशलाकया चक्षुरुन्मीलितं येन तस्मै श्री गुरवे नमः. The 3-mark questions I was discussing in previous video. This trigonometrical questions. 27th question, that is, if x equals a sin theta and y is equal to b tan theta, prove that a square by x square minus b square by y square equals 1. Simple. Let us go on solution. That is, given that x equals a sin theta, so it can be written as x by a equals sin theta. Taking a on LHS comes in the denominator, and a by x becomes 1 by sin theta when it is made reverse, that is inverse. When we take the inverse reciprocal of this becomes 1 by sin theta and can be written as cosec theta. We know that 1 by sin theta is cosec theta. Okay. And y equals b tan theta, and y by b is tan theta, and b by y becomes 1 by tan theta, and that is cot theta. So we got a by x and b by y. Okay. We have proved that the square of these individuals equals 1. Subtraction of the squares of individuals equals 1. Okay, that is what we have to prove here. That is, a by x, a square by x square equals a minus b square by y square. That is, a by x, we know a by x whole square minus b by y whole square, we know, that is a by x is cosec theta, that is cosec square theta, and b by y is cot theta, that becomes cot square theta. We know the relation that 1 plus cot square theta equals cosec square theta, and the cosec square theta minus cot square theta becomes 1. Okay, you know, cosec square theta minus cot square theta becomes 1. Okay, so answer is a by x square, a square by x square minus b square by y square equals cosec, this. Okay, a square by x square minus b square by y square equals cosec square theta minus cot square theta from above, and that becomes 1 using the trigonometrical identities. Okay, you know the trigonometrical identities. There are 3 trigonometrical identities, that is, you know, sin square theta plus cos square theta equals 1, 1 plus cos square theta equals cosec square theta, and 1 plus tan square theta equals sec square theta. Okay, these three you have to know, and that helps. Okay. We solved a square by x square minus b square by y square equals cosec square theta minus cot square theta using and that equals 1 using the trigonometrical identity 1 plus cos square theta equals cosec square theta, and we arrived at the result, and that becomes equals 1. So hence it's proved. And next, go to the next problem. Is here you have to prove that sin theta minus cos theta plus 1 divided by sin theta minus cos theta sin theta plus cos theta minus 1 equals 1 by sec theta minus tan theta. Okay, this we have to prove. That is, prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 equals 1 by sec theta minus tan theta. You have to prove this. It's also a 27 problem. Let us prove this. We take LHS. Taking LHS equals sin theta minus cos theta plus 1 and divided by sin theta plus cos theta minus 1. So we can write here as divide the both. We have to arrive at a sec theta, and in the RHS we have sec theta which is reciprocal of cos theta, and have tan theta which is the ratio of sin and cos. Okay, we can divide both numerator and denominator here by cos theta. Okay, divide, what is this? Dividing both numerator and denominator by cos theta. That is, LHS equals sin theta minus cos theta plus 1. When we divide here, it becomes cos theta by cos theta, and here it will be cos theta whole divided by sin theta by cos theta plus cos theta by cos theta minus 1 divided by cos theta. We divided both the numerator and denominator of this equation by cos theta and arrived here, and sin theta by cos theta becomes tan theta minus 1. Cos theta cancels and it becomes minus 1 result, and plus 1 by cos theta is sec theta. Okay, secant theta. Here it is tan theta. Similarly, plus here cancels, remain 1 plus 1 here minus sec theta. Okay, this you have to get from here, and that we have the both sec theta and tan functions here, and we have to eliminate this one. Okay, for that what can we do is tan theta plus sec theta minus 1 and tan theta minus sec theta plus 1. Okay, can be reorganized, and after that minus 1, okay, that is 1 can be replaced by in the numerator, okay, not in the denominator, because we have to make this numerator as 1. So for that we have to replace this, use this 1, and we can write this 1 as, we know that it can be written as, we have a trigonometrical identity, that is 1 plus tan square theta equals sec square theta. Okay, for that one can be represented as that is secant square theta minus tan square theta, and dividing, and here we have to rewrite this as it is plus 1, and here this can be written as tan theta plus secant theta minus is square bracket use square bracket, and this is in the form of a square plus b square. Okay, and here we have to use this a square minus b square formula, because here the functions these tan and sec theta has to be cancelled. So for that we have to convert these, remove this degree of 2 is this in the form of square. We have to make this their degree is 1, that is sec theta. We have to make sec square theta by 2 sec theta, and tan square theta to tan theta, that is remove this degree as square degree, that is use the a square plus b, a square minus b square formula, sec theta plus tan theta, and other term is sec theta minus tan theta minus secant theta plus 1, the denominator, tan theta plus sec theta. We can take that in these two terms, we can take tan theta plus sec theta, that common. Okay, that becomes what, 1 minus sec theta minus, this becomes plus tan theta, that is minus into minus plus, and this tan theta plus sec theta is taken common outside, and hence the further process is tan theta plus, this here tan theta plus sec theta, tan theta minus secant theta plus 1, and further going tan theta plus secant theta, and here this can be rewritten as tan theta minus sec theta plus 1, and here it is tan theta minus secant theta plus 1. Here we have these two terms same, that is tan theta minus sec theta plus 1 in the numerator, and as well tan theta minus sec theta plus 1 in the denominator can be cancelled both, and the resultant is tan theta plus secant theta LHS. Okay, this is equals RHS. Is it? No, it is not equals RHS. We have to arrive at 1 by tan theta. We have to arrive at 1 by sec theta minus tan theta. So we have to go further solving. That is tan theta plus secant theta is there, multiply and divide by sec theta minus tan theta, dividing, we have it is sec theta plus tan theta, we can write it as LHS can be written as sec theta minus tan plus tan theta. We are multiplying this by sec theta minus tan theta and dividing by the same sec theta minus tan theta, and here it observe that in the numerator we have sec theta plus tan theta into sec theta minus tan theta, that becomes secant square theta minus tan square theta, and the secant theta minus tan theta. You can write this as, we know this, that no, that 1 plus tan square theta equals secant square theta, and therefore secant square theta minus tan square theta becomes 1. Taking tan square on RHS, it becomes minus tan square and equals 1. Therefore LHS becomes 1 divided by sec theta minus tan theta becomes RHS. Okay, now you can see we have the same. Yes, we arrived at RHS. Yes, RHS is here. You are having in this page. Yes, arrived at the RHS as 1 minus secant theta minus tan theta. Okay, so it is how we have to come at the solution. That is, given the problem, we have to prove that it equals 1 by secant theta minus tan theta, and take LHS and divide the both numerator and denominator by cos theta, and dividing which we have here as a result tan theta minus 1 plus secant theta divided by tan theta plus 1 minus secant theta, and tan theta plus sec theta minus 1 and tan theta minus sec theta plus 1 after arranging, and this 1, okay, plus 1 can be written as replaced as sec square theta minus tan square theta, and solving further, taking common tan theta plus secant theta, we have 1 minus secant theta plus tan theta in the bracket, and the numerator and denominator is also having that same term, tan theta minus secant theta plus 1. Both can be cancelled. The remaining is tan theta plus secant theta. Here we have to we need secant theta minus tan theta in the RHS, and as an answer, so we have to multiply and divide this by secant theta minus tan theta. Multiplying and dividing, we have secant square theta minus tan square theta using a plus b into a minus b formula equals a square minus b square, and we know the identity that 1 plus tan square theta equals secant square theta. So this numerator becomes 1 and the result equals RHS. Okay, thank you for watching. Please don't forget to subscribe, like and share. Thank you for watching.